But I'll record it anyway. I can publish
Yeah.
them.
All right. Am I muted? Okay, I'm not muted. Yeah, so I guess the current status is manual capture is kind of looking good. We still need to do some cleanup, especially around which expressions we pick for a span, and making sure arrays are being handled properly. Other than that, we ran the test suite last week. We had a couple bugs around just how BotCheck currently does span, but it's all looking good. I did a quick rebase last night, and the only failures that I saw were around things that I hadn't cleaned up, or what's the better way to put it? So I added a bunch of new test cases. I just haven't annotated them with this is where error should be. So that's the only thing that failed in like the first set of tests. So that's good. After changes Roxanne made got merged in. So what I'm hoping is over the coming weekend, we kind of start doing code cleanup and start fixing whatever little bugs around expressions and stuff is left. My question.
FeatureGate or the
I did.
testing infrastructure you talked about?
Yeah, I did. Yeah, I can show you what that looks like, or what the output looks like. Give me 1 second. Let me just share my screen. It's going to be easier this way. Wait. Where is share screen? How do I share screen on Zoom? Do I need? Oh, that's where that is.
I need to get permission or something.
No, it was just the more screen thing that I ignored. Okay, can you see my screen?
I see. Yeah, I do.
Okay, so I added this. Oh, yeah. Okay. I'm just gonna reset this, I guess.
Oh, okay. I was gonna say, what is that command?
No, it's yeah. Okay. So basically, let's just take some simple error. So let's just go with okay. Let's just go with simple struct min capture.rs. So we have a very simple test case that just ensures that minimum analysis meets both the path requirements and also the capture kind requirements. So basically, we have p.x by immutable borrow, p by immutable borrow. We want p to be overall captured by p to be captured by immutable borrow. So the output for this kind of looks like, and I guess I should just split my screen. That would have been the smarter way to handle this. So first of all, since I have this feature get set, which is captured as joint fields, I see this message is saying, hey, I'm using the new style analysis. Then it just prints the closure ID and kind of prints all the places we captured for it. So this one is the first place we see. So we're starting off at our her ID, which is p. Sorry, var root variable, which is p. Then we apply a projection to access the field, and there's capture information for it. Similarly, this is about the full point. We don't have any projections. This is the first pass. Then it prints the minimum capture analysis, in which we capture only the we capture the full place because there are no projections, and but then it turns into being a mutable borrow.
The second, okay, yeah, you lost me about halfway through. This second little chunk of text that we're looking at now.
That's the after min analysis is done.
Is this okay? This is like the reduced version that you translate to other style data structures. Okay.
Yeah.
So I have a few comments, minor points, but this looks great. First of all, it's cool that it's working. The one thing that might be useful, the problem with this output that I see is that it's so detailed that people are going to be like not able to deal.
That's fair.
No, it's not that big a deal because you run with -- bless and it like gets updated. But I'm worried that if it changed, no one's ever going to like really inspect it. I'm wondering what I think would be useful if we can do it. Let me show you. Okay, go back to the RS file.
Hold on, that.
If we can do it, if instead of dumping the standard out, you actually generated real errors.
Okay.
Then it would. now you can't dump all this information in an error, but just for a second, let's ignore that problem for a second. If you did generate real errors, the advantage is you have to actually put those in the RS file. So that makes them like we actually
make sure. Yeah.
Make sure that you don't accidentally bless things that we're not supposed to change, but you really do want to capture, in that case, just the information that really shouldn't change. So including things like def IDs and so on can be a problem because then somebody refactors how the compiler numbers stuff and all of a sudden like, the file's out of date and it's a pain in the ass.
That's fair. Yeah.
I think what you would want would be, if you go back to the top part for a second.
Of the error, of the standard out.
Yeah. So like, okay, the new style capture analysis,
that's just.
No, we don't need that. But the you could put it as a warning or something.
Yeah.
But like here you see it captured the base upvar and then a projection .0.0 and it has this capture info that it's a mutable borrow. I could imagine issuing an error on the line of the closure that said, ideally it would print like p.0.0 and mute or something, something kind of human.
We can go implement like the display trait or implement debug ourselves for projection. Projection
kind of custom code, right? That like generates the string that you're going to.
Yeah, that's fair.
But mainly it should be really human readable, and it should be like the essence, and it won't help you debug. You'll need the existing output you need for when you're debugging weird behavior. But
okay, yeah. Let me quickly pull something up. Maybe something like. So maybe something like this, but a little bit more.
Yeah, like that.
Like
something like that would be great.
Yeah, maybe a little more easier to work with the machine, but yeah.
Right. It doesn't have to be perfect, and like .0.0 is just fine. But
yeah. Okay. Yeah, I can look into that. Yeah. Actually, it might be interesting how that works out because it's possible we have multiple sets of projections. So. I'll have to think about it a little, how that gets applied. So let me just give another example. Multi-path, okay, that one, and not standard error.
Oh, one other thing about that weird annoying thing about attributes on expressions. You could put the attribute on the function that contains the closure.
I tried that, and then I had to do some things about getting. Yeah, I think I would have to get the parent body, and I don't know. It did not work out for some reason. I might have done some mistakes, so I'll take a look again.
Like closure-based def ID or something.
But yes.
Anyway, it doesn't.
So, like, if we have something like this, so we have like 2 levels of paths that we are capturing. Then we will have.
Oh, you mean like w.x?
Yeah, w.p.x. So we will have multiple projections. So you might, like, the way I'm thinking is then it might be, wait, whoops.
Why do you have
because that's the way things are defined.
Yeah, okay, sure.
But sorry?
Why is that a problem?
Oh, I'm saying I'm just saying I might have to do something like this, brackets, and then comma separate the projections to give a better idea what's happening.
I see. Yeah, that's fine. Just some output.
Okay.
I might imagine something like. So I didn't realize. I didn't realize, but the field, those zeros that we see there, those are like. The first is the variant, and the second is.
And the second is the field, or the other way around. But yeah.
Yeah. Some output like w dot parentheses 0:0 dot parentheses 0:0 or really any output.
Okay, yeah. So I think that's really this. We have a bunch.
What I will say is, I think putting the energy to make this debug output will not only make the test more readable, but it may pay you off. I often find it pays off down the line when I'm debugging and I'm like, I don't have to wade through so much so much detail to get the sense of
No, that's fair. I'll turn these into the debug statements and turn these into logs.
Yeah, cool. All
Okay.
right.
So that's this. I have a couple questions around how we want to merge once this is sort of ready. So do we want to, so what's going to happen is if people use this without, with the feature flag set, it's going to tell them that the feature is incomplete, so it will not work. And somewhere down the line, let's say we do not have the bridge, it will ICE because the information is stored in, I guess, an interesting way, or like it has precise information, I guess. I don't know what error it will be, but I suspect that there will be some error if we just use the output out of minimum captures directly without a bridge, which I guess is fine from the standpoint of like if it has already given a warning saying this is an incomplete feature, so this is kind of expected. Or we can again just some point in the later say, oh, if this feature flag is set, it's failing because this part of the code base has not been fixed, or like parts of this feature is not implemented.
Let me understand what you're saying. So if you set the feature flag, then you're going to gather the precise information.
Mm-hmm.
And you're saying you have this bridge, which would convert to the old style of information from the precise information.
Yes.
You're saying if you don't land the bridge,
mm-hmm.
then you won't have the old style information, and so it's going to ice and bad things are going to happen. Is that right?
Bad things will happen if the feature gate is set, because now we are, okay, so basically if this was without the feature gate set, then what this will look like after minimum analysis was really be foo is being captured, right? Like on my screen. So it will really look like, oh, foo is being captured by something. Similarly, bar is being captured by something. So that's fine. And I can just look at the first index within this array and I'm good, because that gives me all the information I need. But if someone has a feature gate set, it will look like, well, I wasn't supposed to do that. If someone has a feature gate set, it will look like as it did, which means it might pick up the correct, what's it called? A variable to capture, but it's possible that it does not pick up the correct borrow kind.
I see. So what you're saying is that it's a little different than I thought. If the feature gate is not set, it still builds the same data structure. It just builds it differently.
It builds the same data structure, but it will work fine. If the feature gate is not set, all test pass, everything is good. And I'm assuming this will be the case when I remove the bridge as well.
I don't think it's a problem.
Okay,
I don't think it's a problem that the feature gate makes weird things happen. Like we are issuing the warning.
Okay.
That's what it's for. I don't quite understand the bridge. I'm feeling a little confused. This data structure you're showing me here that you.
So, okay, so this is okay, let me make this better. So this is just a heading. So this is minimum capture result. And this is convert to, and then it converts to one, creates the closure captures. Two creates upper capture map.
So are you saying that if the feature gate is not set, then the minimum capture result looks different?
No, if the feature gate is not set, minimum capture result will look like, okay, if not set, this would really look like, it will look like what you expect it to look like from that. So it's exactly what it should be.
And then
if it's not set, then then I'm assuming it will be fine. Like we haven't removed the bridge to test this out, but this will look fine.
So wait, but is anybody reading that minimum capture result apart from the bridge?
Not right now. That's the point, because at some point we need to remove the bridge, right? Because when we get to MER, and we need that information. Well, the information is still there, but we need to start replacing things.
Okay. So
my question is, if, like, we ideally once this feature is ready, we do not need this, because that's actually just duplicate information.
Yes.
So how soon do we want to remove this?
Right.
Is, I guess, a better way to ask my thing. Do we want to land something which has duplicate information lying around? Or do we want to remove this but have most of, and I'm going to suspect that most of the places where the feature get is used will not work. Question is, are there people who are like, there's really at this point no upside to using the feature gate because A, it's incomplete. B, it's actually just adding more steps to the compiler. So there are no benefits and they're just possibly downsides.
So I see a benefit to land. I mean, usually I prefer to land things in master because it saves you rebasing pain and
No.
stuff changes frequently and so forth.
Yeah.
So the only concern that I see with landing, I had assumed we were going to land it with the bridge.
Okay, I'm fine with that. That makes it easier for me. So
the only thing I can see that might be a concern about that would be that it's going to take more memory. I don't know if that's significant. We can certainly measure that as part of the PR. I have one question about the minimum capture result. That's currently in the type check tables, right?
It is, yes.
Is it plausible that we do not put it in the type check tables? Like, could you store it locally and feed it to the bridge and then later add it to the type check tables?
Actually, it is. Actually, it's probably not in the type check tables because I just realized I haven't done the write backstage.
Oh, well, there you go. Even better. Because yeah, if you didn't have it in the type check tables, then the memory usage is going to be just transient, and I'm really not worried at all.
Yeah, it's part of the maybe type check tables that gets built on during, because we need that information when we deal with nested closures. But I just realized that the write back stage is missing, so I'm gonna go document this before I forget.
Yeah, you should open the issue on that, but it would be okay to land it in that state since it'll sit.
Okay. Okay, that makes this a little, yeah, okay. That it's easier and quicker to deploy this. Okay, my second question, follow up, I guess, with this is, is there a way on GitHub for us to test with the feature flag set on all the testing we do? I have two options on how to do this, but I'd like to hear your thoughts with, like, assuming that the feature gate was set and we have the bridge, is there a nice way on GitHub to run the test suite?
I mean, no, like yes and no, right? If you just do it by default, it obviously won't run because tests don't have the feature gate. So you could push a commit that
it just assumes it's true.
Assumes it's true. Now,
that's what I was thinking.
That would apply during bootstrapping, but that'll certainly run CI, right?
If it's using xpy to build, similar to just like if I do xpy build, and then it should be fine because that's how I've been building and testing things locally. So I don't think that will cause a problem.
Yeah, so that's the easiest way, is to just trigger CI by pushing a commit and then not landing it. I also think if you wanted to add an environment variable, this doesn't make any sense for CI though. If your goal is CI, this won't help. But if you wanted to have an environment variable for local testing,
that's what I've been doing so far, yeah.
And you could add that too. I mean, it's perfectly fine to say if the feature gate is enabled or this crazy environment variable is enabled, then
that's how we have been testing locally, is with using the environment variable.
It's possible for sure to, modify the testing harness to supply that environment variable. That's another kind of commit you could push to CI that you don't land, but
okay.
I'm not sure how easy that would be.
Yeah, that's fair. So I guess the memory user will be fine. Okay, so I guess I don't see too much work around here that's left on this. Do we want to run capture analysis with the bridge? Sorry, perf analysis with the bridge to see how much extra impact it has had?
You might as well run it. I mean, it's easy to do. I don't anticipate a problem, but
Yeah, I know. main reason I bring this up is you had some comments in the plan documents that this, so I'm not sure how much impact this will have. Like, it isn't too much code, but it's significantly more,
Yeah,
more analysis. So there's going to be impact. I just don't.
I think I wouldn't. It's not a top primary concern of mine, but once the PR is ready, we might as well run a perf
Yeah.
analysis.
Okay, that sounds good. I created an issue. I'll put this on the project board. Give me 1 second. Actually, I haven't looked at this, but for the most part, I think most of Clojure captures has been replaced, which is a good thing.
Actually, can you wait 1 minute? I'll be right back.
Okay, yeah, sure.
Okay.
Yeah. So yeah, I was gonna say liveness.rs has some. I think is one of the other places that was mentioned that we might need to.
I have a question. When you said that the uses of Clojure captures has been replaced, did you mean that what is it using instead? And is this
Oh no, I meant upfar's mention has been replaced by Clojure capture. Sorry.
Okay.
So post type check, we would use the things we built in type check. Yeah, yeah. Sorry, I misspoke.
You're still using the older data structures.
It is using the older data structures.
Fine.
Let's
that makes
see.
sense.
So there's some use of upwards mentioned here that I.
One more question. Do you plan to land this work, like, how does this relate to the minimum captures? Would it land independently before?
No, it will land with, because some places basically min capture won't work because, well, it will work. The test cases fail because the thing is with min capture, there are places where it changes the order of than upwards mentioned, which causes inconsistencies in parts of the compiler.
Okay, very well. All right.
So
this is liveness, yeah, okay.
This is liveness. So there's some analysis that happens over here to figure out if basically certain variables, if they were mentioned in the Clojure later, let's say they were mutated, were they ever used again? And at least that's how I understand at a high level what this part, like this file kind of does. My question is, how does this change when we start doing precise captures and stuff? Because let me see if I can find that comment. There's a comment saying that, or at least I remember when the last time I looked at this was interesting places is the, I think, name. Yeah, so there's, give me the, or field. Give me, I'm gonna just expand all of this and quickly run through the file. This one. Yeah, so something around here. Yeah, so we do not do liveness analysis on, or looks like are not. It seems like we probably don't do too much work around with when we go to precise locations. Are we planning on doing? Do we just do the same thing? Just I'm assuming we do the same thing with Clojure as well.
I think that's right. Yeah, this is really just at the level of variables. This code is pretty old and a bit crusty, but I think we should be able to translate it in a relatively straightforward way.
Okay.
If you want me to look at it in more detail, I can do that.
Yeah, I'll let you know. I didn't get too much time to go through this myself, but I did a high level check of like what all needs to change. So that's why I was just wanted to like get if there are any high level concerns that you're aware of before we go and spend too much time figuring details out.
Yeah, the change that allowed it to work through closures, I remember that landing, and that code.
It was around June or something, possibly.
Yeah, I might have to familiarize myself with that code. I probably R+'d it, but I don't really remember that detail of the change. The basic logic before that was pretty straightforward. I mean, a closure was kind of accessing its upstairs.
Let me see if I can find the commit. But yeah, I'll go through the PR. Maybe that will help. Okay, that's actually November. Some of this, or May. Wait, what did I do? What did I do? Okay, I'll look through this. Are you
familiar with liveness analysis in compilers?
Sorry, I have a very high level idea. I know it's actually. I think you should just explain. It would be easier.
Okay, I mean, the basic idea is that at each point in the control flow, you maintain a bit set, or at least a set anyway, of what variables are live, meaning might be used later.
Okay, yeah.
And you do this, you start from, this is a backwards analysis, because you kind of start from the end, and at the end, nothing is live, right? Because
yeah, that makes sense.
Then you go backwards, and when you see a use of a variable, you add it to the set. Because now that it got used, you know everything that came before that, like whatever value, that must have stored the value somewhere before.
Yeah, somewhere, yeah.
So it's live up until you see an assignment, and an assignment takes it out of the set. Because that point, whatever was in there before no longer matters because it got overwritten.
Yeah, yep, makes sense.
And you propagate this until you reach a fixed point, and then you're done. That's the analysis.
Okay.
And of course, when you have two paths of control flow, you take union.
Yeah.
If it's live on either path, it's live in the predecessor because, you know, there's like, you have one node with two successors.
Yeah.
But we're going backwards. So
yeah,
either of those successors has a variable live, then the predecessor.
Yeah, makes sense. Yeah, makes sense.
That's the basic analysis. What we do for closures, like the simple version of what we do for closures is a closure expression is considered to access all of the variables that it captured.
Okay.
I don't know exactly what they changed. That's the part where I have to look. Like this commit, I have to go back and reread this PR to see what they changed.
Okay.
A high level understanding. And if when you see these things like when it says live node, that's just a node in this control flow graph.
Oh, okay.
And we don't actually, I don't remember, but I don't think we actually build a control flow graph explicitly because this code predated Mir and some other stuff. But instead what happens is it constructs a set of nodes and it stores a set of bits per node, but then it walks the here to like construct the edges between the nodes, if that makes sense. So
kind of
correspond to things from the here. So you can see like X per node.
Yeah.
Right?
Okay, there's closure and upward node. Wait, there are two closure. Okay, interesting.
There's a whole bunch of nodes there, but one of them, those are different kinds of nodes, right? But one says X per node. That means a node that corresponds to some here expression. So then if we want to propagate and we go to like a here expression, and then we go from reading the here, we can kind of see what expression would evaluate right before that one.
Okay.
And we can say take all the bits from the successor and propagate them to the predecessor.
That makes sense.
I have to,
Okay.
yeah, that's the high level view. Anyway, we can walk through the code later if it's useful, but
Okay. That makes sense. And I think,
so you see this IR maps, yeah.
Where? Oh, the one below. Okay.
Down for, let me just read what that does. Yeah, so a liveness node is an expression or capture clause that does something interesting. Okay. Yeah, so this is the first pass, and then if you page down a little bit more, you'll come to the second pass, which
I don't know. Okay, let me go slowly. I don't mind. Sure. Yeah, if this is the visitor, this is the same visitor that's used in most places in her.
Yeah, yeah. And this is just finding this. This isn't doing any real work. It's finding the set of nodes and the set of variables. And
okay, so this is some work on closures.
Right. So here it would say, here it's first it creates a liveness node. That's the first line up above where you are. And then right. Okay. I'm not sure why I guess we use liveness nodes also for variables. I don't remember that, but okay. And then then it's basically finding the set of captures, right? Like call caps, that's the captures. I see. What that probably is, oh, okay, now I see what it's doing. So I think what's happening here, this is, I think, from the change they made, is that it's storing what are the things captured by this closure. What I imagine is going to happen is when they see a call to the closure,
all of these will be marked as live.
They'll probably, yeah, I assume that's why they called it call caps. I don't know. Anyway, but I'm sure they're obviously going to reference this later.
Okay.
You scroll down a little bit more and then I'll stop walking you through. But this part, computing liveness sets, this is where it actually does the propagation. And
I see.
Anyway, that's enough of a walk, but you'll see somewhere in there that it does a similar visit of the here and like propagates bits from one place to another.
Okay, makes sense. While looking through this, I realized one thing that we did, and I think it's fine for now. We need to change it later, but let's see if this works. It did, nice. I think it was mod.rs, let's see. Maybe, I think this one. Yeah, so right now in mod.rs, we use just, it's kind of more of a, I don't think there should be an issue, but we use the upwards mention span to get information. It was using upward mention directly, but this is just to get places in order. At some point, this will get replaced by min capture, so it will have its own use expression ID, so we can just get the span there. This is just to land the bridge for now.
It seems fine.
Yeah.
Just using up as mentioned is not a big deal as long as it has a plan to be replaced.
Yeah, and let's see. Let me just ask. Let's see this. Okay, nice, that worked. Let's see. And yeah, I have one question around, let's see, path to the axis. So I have this kind of a simple situation. I have a point. I create a pentagon, so it has like 5 points, and we have this. What I was expecting for this was, and I'll open the standard out. Okay, was that this thing will have 2 sets of projections. So, or more like 3 sets of projections. So four really. Pentagon will have a dereference. Then points will be a field axis. Then we do an index axis to get the array. And then we do another field axis on that to get the final place. We seem to only be doing, what is it called? A single projection to get the type, to get the points field. And I was hoping to see at least a dereference here, but I guess it's moving it for some.
So
Well, it's not.
no, I think what's happening is you don't get a dereference because I think the reason you don't get a dereference is this is in the upvars analysis code.
Mm-hmm.
It has not yet figured out whether that is going to be a by value, like a move or not.
This is part of the memory categorization code,
Right.
which knows derefs.
Yeah, but so the reason you're expecting a deref, if I understand, is because this is an upvar. Is that right or not right?
Yeah.
And so what you kind of expect is that P pent is going to get translated to like self.pent, star self, you know?
Kind of.
And there's code to do that, but let me look real fast at VS Code to refresh my memory. But the thing is that the code that would do that has to read the upvars table. Like it has to know how the upvar is captured in what mode in order to know whether or not it needs to introduce ref. And the problem is when you first analyze the code, we don't yet know what mode it's in.
Interesting.
So I think now, actually, I think this has probably all been refactored now that I'm starting to remember, because I think the only place we use the mem categorization code anymore is in
closures,
right?
Yeah, it's mostly for closures and Clippy.
Right, but okay, Clippy, yes. But I mean, within the compiler, it is only used for the closure analysis, which probably means that it never runs at a point where it actually knows that information that it needs to know. So
give me 1 second. So that is filter on. Okay, I guess this one makes sense, but let me just. Nope. Which one is? Okay, that one. So in this we do see a deref, which I guess makes sense because we already have it's dereferencing from self.
I think yes, that deref is coming from self.
Yeah, so I guess that makes sense.
So I think you're basically seeing, it looks like the places you're getting are like what I think of as how the user would think of it. So the base says an upvar, the implicit derefs and so forth that are associated with being an upvar, like they're not getting added.
Okay, I guess that answers the
pentagon. The type is not ampersand pentagon, right? So
yeah, it's not ampersand pentagon.
You wouldn't want a deref there.
Okay, I guess my second question is why do we stop at points and not have anything high, more than, I did an index axis and then I did a field axis?
So I believe that's because, I'm not sure why this falls out in the code exactly. I have to read the code to explain it. But we can't capture, if you recall, we don't want to capture like a specific.
Arrays. No, that bit I understand. I know because I was planning on putting in code to make sure that indexes, the moment we see an index, we ignore things, and there's already some happening. So that's why I'm
yeah, go on. I think I might know why, but
like my point was like I want to make sure that test cases that ensure that level of detail, which is kind of like the only you go ahead and I'll show you how I was able to get an index.
Okay, so I think it might be because the index is a overloadable operator that derives to a trait call. And so when the compiler analyzes what pent.points of 5.x looks like, it actually sees first take a reference to pent.points. That gives you a reference to the array. Now I call the impl with that reference and the number 5. And that gives me back a temporary reference, which I then use to access X. And so in terms of the actual accesses,
Mhm.
the only one that goes to an upvar is pent.points. I suspect that's why.
Wait, so from what I remember was, I think you're right, because it says if there's a function call versus if it's the actual implementation to access a field, then one gives the index and the function call would not. For arrays, shouldn't the array access be, is it implemented the trait, like the trait stuff that you just mentioned, or should it not be the, like kind of a built-in access?
So I think what we do is we have a trait,
Mm-hmm.
and in the type checking phase,
Mm-hmm.
we start by sort of putting it through the trait, but later convert it to a built-in operation.
I see.
I have a memory of this, but I don't remember exactly when the later is. And it may have, but it may be that it comes after. I think it's in write back, I want to say, that there's some logic that says like, if this is, I know for, let me find it. I'm pretty sure it's true for plus. It's probably true for index too, where it kind of says, if this turned out to be the well-known thing, then let's make it the built-in plus.
Okay, I see.
So it might be that by the phase you're at, you haven't yet done that.
Okay. I mean, this doesn't really cause problems, so
right.
It's a little helpful. Yeah. While you pull that up, let me pull up the.
Test slices too.
Yes, that's a slice pattern. That's what I did to get the index.
Good call.
So, yeah, so slice gets me the index projection. But yeah.
I'm pulling up. Let me see. So slice gets you. I'm looking now. I see. Okay.
And so right now, this is like, as I said, we still need to handle arrays properly, because the minimum analysis should be like, I saw an index, go back up and not take one projection before, kind of, which would basically turn this into an empty.
Yeah. Okay. Is that the only thing you see is the index pattern? I guess that makes sense.
Yeah, because from what I know, this will resolve into subslice, but that just gets kind of ignored because it's not really, it cannot be used.
Yeah.
The subslice we get.
Well, that's probably because, I mean, this kind of fits my hypothesis, which is that because these slice patterns are not desugared through any kind of trait, they're just directly indexing.
Oh, okay, I see.
You can't use them on vectors, for example.
Okay. Yeah. I started with vectors and realized, okay, that would definitely not work because that's a method implementation, so trait implementation. So yeah. Okay. Now that makes sense and eases my workout, so I'm not gonna go fight that one.
Right.
But yeah, other than that.
Okay, if you look at, there's a method called search for fix underscore scalar underscore built-in expression.
Wait, fix or fixed? Okay, that. Okay.
Although it doesn't seem to apply to indexing, but anyway. Oh no, there is another one. Yeah, search for.
Yeah, there's two, I think.
Oh, down below, there's one called fix index.
Oh.
There you go. So stream indexing is overloaded until write back, and then we go through and look for like cases where it's built in and we use it.
Okay, sounds good. All right, okay. That's all I have in my mind. We discussed the bridge, we discussed perf, and I got answers to the index stuff. Yeah, hopefully this weekend we clean this up, and I'll work. I'm assuming Dhruv and Archer are probably gonna work on cleaning up some of the how we output the standard out, and or more like move it to standard error. And yeah.
Did your other PR land?
Yeah, it merged in last night.
Great. Okay.
Yeah. So if we want to look at the project board, let me just share project board. Let me know if you want me to reduce the size of the screen. This is, I'm going to edit this a bit more and add some details, but hopefully this week or midway through next week, we have all of these in review. Type check using closure captures will be mostly done as part of these. So less worried about that. And writing min-cap, I'm assuming we can just do the write backstage when we do the model lowering, because otherwise it doesn't add too much value.
Yeah, that makes sense to me. I would do those together.
Yeah, so, and updating error logging and borrow code. I don't know why I tagged it with this, but that will also just go with more. So,
wow, that's super exciting. We're actually getting there.
Yeah.
All right.
Yeah,
cool.
this is, all right. Yeah. Okay, that's all I have. Do you have anything else for us?
Nope. This is great.
All right. All right. Thank you.
See you next week.
See you next week.